Binomial Probabilities, Part 2. You should be familiar with the basic notions of probability, including combining events with and, or, and not, Pascal's triangle, and its connection to counting combinations. You should also be familiar with binomial probabilities for coin flips, where the chance of success is 1/2, and with the concept of random variables. In this lesson, we will calculate probabilities in successive trials with two options, even if the chance of success is not 1/2. Recall the binomial probability model for coin flips, where each string has equal probability. The numerators are found from Pascal's triangle. The denominator is 2 raised to the power of the number of flips. What happens when the chance of success is not 50%? Suppose a basketball player shooting a free throw is a random event with a 70% chance of success. There are 4 possible strings of made and missed free throws. To find the probability of each, we multiply the probabilities. For instance, making 2 free throws is making the first free throw and making the second free throw. Notice that Pascal's triangle still appears. The number of strings of free throws for 0, 1, and 2 successes are 1, 2, and 1 respectively. These are the numbers in the second row of Pascal's triangle. The difference is that the probability of any given string depends on whether they are made free throws or missed free throws, since the underlying probabilities are different. Also notice that for each value of x, the probabilities of the separate strings are the same. For example, the probability of making the first and missing the second is the same as the probability of missing the first and making the second. They both multiply the numbers 0.3 and 0.7 in some order. This will be true for any number of shots. We are merely rearranging the placement of the numbers, but they are the same numbers and we get the same answer when we multiply. Now let's shoot 5 free throws and find the probability that 3 are made. From Pascal's triangle, there are 10 possible strings of 3 made and 2 missed free throws. The probability of any such string is 0.7 to the third power times 0.3 squared. There are 10 strings in all, so the total probability for getting the first string or the second string, or the third string, etc., is to add the 10 possibilities together, all of which are the same product. So in total, we have 10 times 0.7 to the third power times 0.3 squared, with the 10 coming from Pascal's triangle. In general, to compute the probability of getting k successes in n attempts, find the number of such strings from Pascal's triangle and multiply the probabilities associated with the successes and failures. Here's an example. You may wish to pause the video to work out the answer. There are 4 choose 3 or 4 possible strings. 3 shots are made with 65% probability and 1 missed with 35% probability for a total of 38.45% chance.